Today, our lesson is how to measure and classify angles. The first angle we're going to look at is called an acute angle. I can remember the word acute because it reminds me of a small dog, and when I see a small dog, I'm like, oh, that's so cute. So this is acute angle or a cute dog, right? And this measure is between 0 and 90 degrees, so I would say 0 less than angle A, less than 90 degrees. Notice it is not including the 0 or the 90, it has to be between those two. The next angle on our list is a right angle. The measure of angle A has to be 90 degrees, so that is the only possibility for it to be a right angle. Here's a little diagram down here of a right angle. Notice the little square mark in the middle. That is telling me that it is a right angle. So anytime you have a little square mark, that means this is a right angle, and the measure of this angle is 90 degrees. The next one is an obtuse angle. Obtuse angles measure between 90 degrees and 180 degrees. Again, they are not included. It's between those values. Here's a little diagram down here. And you can remember obtuse angles because it's like obese. Remember, obese is like big, so this angle is like a big angle. The last one is a straight angle. The measure of angle A is 180 degrees. It has to be exactly 180 degrees, nothing else. Notice that it forms basically a straight line. That's why they call it a straight angle. Okay, let's see if we can figure out what an angle is exactly. An angle is created by two rays. So we have ray AB and ray AC meeting together at a common vertex here called vertex A. Okay. These two rays form the sides of the angle, and where they meet again is called the vertex. There are a few different ways that I can name angles. The first one is I can name an angle by the vertex if only one angle is present. So if there's only one angle, then you can name it by the vertex. If there's more than one angle, then you can't do that. If more than one angle is then it's named by a point on a side, the vertex, and a point on the other side, in that order. So let's look here. Let's first do the easy one, this one over here. This is one angle only. So I could name it by its vertex, angle G. I could also name it by a point on one side, then the vertex, then a point on the other side. So I could name this one angle FGH, or I could go backwards and say it's HGF. So any of these three possibilities down here for this one. This diagram over here, I cannot name just angle E, because which one am I talking about for angle E? Am I talking about that one there? Am I talking about that one there? Am I talking about this one there? Or am I talking about the big one right there? So you can't name it just by one letter. So there's different ways you can name these angles. So this one right here would be angle AEB or angle BEA. If I took that line out, so it'd just be that. I could name that angle AEC or angle CEA, and so on and so forth. There's a whole bunch of different angles there. The next thing we're going to do is we're going to learn how to measure these angles. So I have a few angles drawn here. I'm going to use my nice little handy dandy protractor. Notice that the vertex of the angle, I'm going to line up with the little dot in the center of my protractor. So there I went ahead and lined it up. One arm or one side of the vertex has to be even. There's a little small black line. Let's see. See, there's a little small black line on my protractor. Make sure that that little black line lines up with one side of the vertex. Okay? And then if you follow it all the way through, it should be all the way over here at 0. So this, if there was this line on top of itself, it would be 0 degrees. Okay? We're always going to start at 0. So notice there's two different marks. There's 10 or 170. Well, we're going to start at 0. And then we're going to count our way up. So I'm going to start 0, 10, 20, 30. So I'm going to use the inside marks measuring this angle. When we measure the other angle, I'll show you, we'll use a different set of marks. So this would be 10, 20, 30. And then if you continue on, it looks like it's going to be about 3 little marks past the 30. So I would say that this angle is approximately 33 degrees. And it's not going to be 100% perfect. I just drew the angle and then I'm measuring it. So we'll look there. So I could say the measure of angle X, I did call it X because I labeled it inside here, or I could label it angle CBD or angle DBC. But anyway, the measure of angle X is approximately 33 degrees. Now let's measure the other one. Again, I got to line up my vertex right on the center there. And then over here, this line, if it continued on, would be right at 0. There's 2 marks again, but remember, this time we're starting at 0, so we're actually going to use the outside marks. And we're going to go all the way around until we get over here. So we're going to go all the way around over here until it gets to about right here, and we're using the outside marks again. So this is approximately 147 degrees. Okay? So angle Y measures 147 degrees. Okay, the next thing we're going to talk about is the angle addition postulate. An angle addition postulate is when two angles share a vertex, and one side, you can add them together, and they will equal the total big angle there. So like the one I just did above, this little example, we said that this one was 33 degrees, this one was 147 degrees. If I use my angle addition postulate, because they share a vertex and one side, then I can say the sum of these measures of this whole entire angle here is 180 degrees. And this, of course, makes a straight line, so it's called a straight angle. The two of them together would form a straight angle. And we'll talk more about angle pairs in the next section. Okay, the next example here says I have angle KLM. It is a straight angle. I want to use that information to find that the measure of angle KLN and the measure of angle NLM. Well, I look at my little diagram here, and I have this information drawn to me. So angle KLN is 10x minus 5, and angle NLM is 4x plus 3. They might draw it for you on a little diagram here. They might not. They might just give you the information listed, and then you would have to draw the diagram yourself and then put all that information in. But it's a great idea to draw the diagram if it's not there. Okay? So once I see these two like this in my little diagram, I know that I can add the two together, and they should equal a straight angle, which is 180 degrees. So I'm going to say 10x minus 5 plus 4x plus 3 equals 180 degrees. Then combine your like terms, 10x and 4x is 14x. The other like terms, negative 5 and 3, combined to be negative 2 equals 180 degrees. Add 2 to both sides to get rid of it over here, and you have 14x equals 182. Last step, divide by 14, x equals 13. This is where you have to be very careful. See what the question is asking you. It is not asking you for x, it is asking you for KLN and NLM. So if you just answered 13 and you move on to the next question, you didn't finish the problem and you will lose credit. Okay, so let's see. Angle KLN is 10x minus 5. I have it here, so I transferred it over here. But now I know what x is, so I'm just going to plug in 13 for x. 10 times 13 minus 5 is 130 minus 5, so the measure of angle KLN is 125. I have the other angle NLM is 4x plus 3. Again, plugging in your 13 for the x. 4 times 13 is 52 plus your 3, so the measure of angle NLM is 55 degrees. Okay, the next vocabulary word is congruent angles. Congruent angles are two angles that have the same measure. Okay, so they have to be the exact same, so 50 and 50.